All right, you guys, we're continuing that secant property, which states if you multiply the outer segment of the secant to the length of the whole segment, that will equal the outer length of the other segment times the length of the whole segment. So basically, the way I think about it, you're doing the outer segment times the outer plus inner segment equals the outer segment times the outer plus inner segment. Okay, which this problem, you guys, is pretty much the same thing as example 3. So if you felt confident with example 3, go ahead and tackle example 4 on your own and see if you get it right. All right, so on this one, we're solving for z as well as the length of each of our secant segments, JG and LG. All right, let's get going. Guys, and again, if you want to look at that slide at the Prezi, again, it's the outer segment times the outer plus inner segment equals the outer segment of the other secant times the outer plus inner. Okay, so in this case, it's like BC times BC plus BA, or AB, equals CD times CD plus DE. All right, so that's the property we're using, so let's get going. Okay, so again, we have two secants in our picture, which I'm going to label that for you because I just think it helps to reference later on. So the two secants we're dealing with in our problem are JG and L to the G. Bam. Alrighty, let's get going. So I'm going to start with JG. So which segment within JG is the outer segment? It is HG, Heavenly Hamburger, you guys. All right, let's get going. So we have H to the G. I'm going to start further over this time since I always seem to run out of space. So we have HG times the length of the entire secant, which I'm going to break down the secant into two segments. We got JH and HG. So that would be J to the H plus H to the G. That will equal the length of JG. So this secretly is JG. That's the length. All right, and that will equal the outer piece, KG, times the sum of the entire other secant, which is this piece, plus that piece. So KG plus KL. All right, let's start filling in some values, you guys. Let's go. Let's do this thing. All right, so HG is 13. So we got 13 times HG again is 13 plus, what's here? Sorry, I lost my marker. Plus JH, which is Z. So that's a Z, you guys. Remember, my Z's start looking like 2's. So I just put that line through it so you know what I am talking about. Okay, so that will be Z. So I'm going to write that down. Sorry, guys. I'm wasting time right now. All right. And that will equal K to the G, which is 9 times KG again, holy hot dog, plus LK, or KL, which is 30. All right, let's start solving, you guys. All right, so I'm going to keep going. So we have 13 times Z plus 13, which guess what? When you have a number outside of a parenthesis, you can distribute that thing. Bam and bam. All right, so 13 times Z is 13Z plus 13 times 13, which is 169. Whoa. Okay, and that will equal, I'm going to distribute over here. You could technically do 9 times 30 and then multiply it by 9, or you could distribute. Doesn't matter. 9 times 9 is 81, and 9 times 30 is 270. All right, let's keep going. So we have 13Z plus 169 equals 81 plus 270. So that's going to give me 351. I'll double check on that, but I feel confident about that one this time. Yes, that is 359. All right, guys, let's solve this thing for Z. Let's keep on going. Okay, so how do I bring 169 to the other side? I would subtract that thing on both sides. Let's do it. 169. Come on, this long. All right, which 169 minus 169 cancels in terms of 0. 351 minus 169. So let's see here. 51, 61, 18. So if I'm thinking correctly, that's going to be 182. but I will double check. I think it's 182, but let me double check. 9, 10, 11. Yep. Yes, it is 182. Okay, I was a little worried about that one. All right, so we got 13z equals 182. All right, so I'm going to divide both sides by 13 now because 13 is secretly multiplied to the z. All right, so I'm going to divide both sides by 13. All right, so z will equal, I don't really know 182 divided by 13. So let's see here. 13 goes into 18 one time, remainder 5, and 13 goes into 52. I think it's 4 times. I think that's 14. I'll double check real quickly. Do some side math just to make sure. Doesn't hurt to always check your work. All right, 13 goes in 18 once, remainder 5, and then 13 and 13 is 26, and 26 times 2. Yes, so that's 14. Amen. Okay, we got this, you guys. We got this. All right, let's keep on going. Keep on going. Okay, so now I need to find the lengths of my 2 secant segments. So I want to find JG and L to the G. So let's get going. All right, so JG, which 2 segments make up JG? It is JH and HG. Whoa, cool beans. Okay, so that's going to be JH plus HG. All right, let's start filling in those values. So JG equals JH, which is Z, plus HG, which is 13. Let's keep on going. And now that you know Z is 14, what can you do with that bad boy to help us find JG? Yes, 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 we do substitute that bad boy in. So let's substitute that thing in. So Z is going to be 14, and then we have plus 13, which 14 plus 13 is 27. Oh, man. And now, lastly, we need to find LG, which 2 segments break down L to the G? Yes, it is. It is LK and KG. So these 2 bad boys added together will equal the whole segment, which is LG. So let's do that thing real quickly. So we got LG equals L to the K plus K to the G. All right, so LG equals LK, which is 30, plus KG, which is 9. And guess what, you guys? 30 plus 9, that's a 9. I know that does not look like a 9. Jeez, Miss Long. Work on your handwriting. All right, 30 plus 9 is 39. And guess what, you guys? We have found Z and the length of our 2 secant segments. Whoa. All right, so the next 2 examples involve tangents and secants intersecting outside of the circle. Whoa, that just looks too cool for school, right? All right, well, I'm not going to go too much further because I know you guys are ready to go. All right, let's get going on example 5 and 6.